Hello everyone, this is the third question of homework 1. And let's first read the question. There is a digital signal 1 or 0 is transmitted through a noisy channel. The received data may be different from the signal sent out. Suppose the transmitter sends out 0 with probability 0.6 and 1 with probability 0.4. When 0 is transmitted, the receiver receives 0 with probability 0.7 and 1 with probability 0.3. When 1 is transmitted, the receiver receives 0 with probability 0.2 and 1 with probability 0.8. So according to the question, we can draw a graph of total event. This is the whole space of events. And first, we can look at the transmitter side. There are only two events. One if either we send 0 or we send 1. So the two events are mutually exclusive and they are in uh, the two events are occupied whole space. So we can draw a line like this. And the left side is send 0. I write the S0 uh, to be like this, and the right one is send 1. So either we send 0 or 1, we can get either 0 or 1, and they are in the both two events, and also they are mutually exclusive. So we can draw a line like this, and the upper one is receive 0 and the bottom is receive 1. So there are only 4 different events. Send 0, receive 0, send 0, receive 1, send 1, receive 0, and send 1, receive 1. So according to this graph, we can get some solution. So let's see the first question. Find the probability that data 0 is received. So what is the probability of 0 is received? Receive 0, there are only two situations. First one is send 0, receive 0 in this area. And the second one is send 1, receive 0 in this area. So we can write the equation like this. Probability of receive 0 in total equals the probability when we receive 0, when we send 0, multiply the probability we send 0, plus the probability we receive 0 when we send 1, and multiply the probability we send 1. So this is the total area, total probability of receiving 0. So we can calculate this like this. The probability of send 0 and receive 0 is in this area. So we can get it in the graph. It is 0.7. Multiply the probability send 0 is 0.6. Plus this is receive 0 when we send 1. This is 0.2. And multiply the probability we send 1. This is 0.4. So we can get them in total. This is 0.5. So this is the solution to question 1. And we can look at the question 2. Find the probability of error. Error has two situations. The first one is probability that 1 is received and when 0 is transmitted, or 0 is received when 1 is transmitted. So this is the error of send 0 but receive 1, or send 1 receive 0. These two areas are the events of an error, so we can write the equation like this. The first one is 1 is received when 0 is transmitted. It should be multiplied by the probability of send 0. And the second part is receive 0 when we send 1. It should be multiplied by the probability of send 1. So this is the total probability of get an error, and we can calculate this by this is send 0 receive 1. This is 0.3. The probability of send 0 is 0.6 plus this is 0.2 and this is 0.4. So the total is 0.26. So this is the solution to the second question.